Today we'll look at lesson 13.3 on solving absolute value equations. It says absolute value equations differ from linear equations in that they may have two solutions. This is indicated with a disjunction, which is a mathematical statement created by a connecting two other statements with the word or. To see why there can be two solutions, you can solve an absolute value equation using graphs. It says solve the equation 2 times the absolute value of x minus 5 minus 4 equals 2. Plot the function on the grid. Then plot the function g of x equals 2 as a horizontal line on the same grid, and mark the points where the graph intersect. So we're going to start with g of x because that one's pretty simple. We are just going to mark it at 2. And g of x is another way of writing y, so we're going to graph y equals 2. Then we also need to plot the function f of x, which yesterday or in the previous lesson we talked about how the 2 is a stretch or a shrink, the 5 is a shift, and the 4 is a shift up or down. So we know that the vertex is going to be 5 to the right and 4 down. Now we need to figure out where those points go from there. So let's plug in some other numbers. How about 8? If I plugged in 8 minus 5 is 3. The absolute value is 3. 2 times 3 is 6. And 6 minus 4 is 2. So we're going to go to the point 8, 2. Okay, so we know that this is headed off in this direction. And then let's graph maybe 2. Oops. If I put 2 in there, 2 minus 5 is negative 3. But negative 3's absolute value is positive 3. 2 times 3 is 6. And 6 minus 4 is 2. So we're going to plot this point 2, 2. So then it says write the solution to the equation as a disjunction, meaning x equals 8 or x equals 2. Those are the two places where it crosses. Why might you expect most absolute value equations to have two solutions? Why not 3 or 4? The reason is because when you're working with absolute value, there are two different numbers that can give you the same answer. So for example, if I had the absolute value of negative 5, that's 5. And if I have the absolute value of 5, that's also 5. So why might you expect most absolute value equations to have two solutions? Because there is a negative possible answer and a positive one. Or you could say there's two values that have the same absolute value. Is it possible for an absolute value equation to have no solutions? One solution, And if so, what would each look like graphically? Yes, it is possible for there to be no solution. And graphically, that might look something like this. Here's our absolute value function, and here's the number that it's supposed to equal. Do those ever intersect? No, because the absolute value function is going to continue upwards, and then the y value function is going to stay below. You can also have one solution. And that would be when the absolute value function crosses that line at its vertex. So here's my absolute value function, and here is my number function. You can see that it crosses at exactly one place. So you can have none, 1, or 2, but you will never have 3 or 4 or so on. To solve absolute value equations algebraically, first isolate the absolute value expression on one side of the equation the same way you would isolate a variable. Then use the rule. It says if the absolute value of x equals a, where a is a positive number, then x equals a or x equals negative a, because when we put a negative value into absolute value, it gives us a positive function. So we have to look at both options, the negative and the positive version. Notice the use of a disjunction here in the rule for values of x. You cannot know from the original equation whether the expression inside the absolute value bars is positive or negative, so you must work through both possibilities to finish isolating x. Solve each absolute value equation algebraically. Graph the solution on a number line. So to start, we have to isolate the absolute value piece. So they start by subtracting 2 from both sides, and now they have the absolute value of 3x on one side, so it's isolated, equals 6 on the other. But then we have to use these two versions. The piece is equal to the positive version or to the negative version. So you can see here they have the positive and the negative. Then they divide both sides by 3, and they get x is 2 or x is negative 2. And they've graphed both of those on the number line. To start B, they add 2 to both sides, so then we end up with 3 times the absolute value of 4x minus 5 equals 21, because 19 plus 2. Then they divide both sides by 3, so they get rid of the 3, and 21 divided by 3 is 7. So we separate it out. It can equal 7, or it can equal negative 7. Then they add 5 to both sides. 7 plus 5 is 12. And then negative 7 plus 5 is negative 2. Then we divide both sides by 4. 12 divided by 4 is 3. Negative 2 divided by 4 is negative 1/2. Then we're going to graph them. X is 3, or x is negative 0.5, or negative half. Solve each absolute value equation algebraically. Graph the solutions on the number line. So for this one, to isolate, we're going to multiply by 2, because 2 times 1/2 is just 1. So now I have x plus 2 equals 20. Now we take out those absolute value pieces, and we do the positive version and the negative version. Subtract 2 from both sides. X is 18. Subtract 2 from both sides here. X is negative 22. So it looks like we're counting by 4s. 4, 8, 12, 16, 18, and then negative 22. For this one, we're going to start by subtracting 5 from both sides. That gives us negative 2 times the absolute value of 3x minus 6, and that equals negative 4. Then we have to divide both sides by negative 2. That leaves us with 3x minus 6 equals 2. Or we have to do the negative version, 2. 3x minus 6 equals negative 2. Then we add 6. We end up with 3x equals 8. And over here we have 3x equals 4. Divide both sides by 3. That gives us x equals 2, because 2 sets of 3 would be 6. And then we need 2 more thirds. Then over here, 1 and 1 extra third. So 2 and 2 thirds. And then 1 and a third would be there. Absolute value equations with fewer than 2 solutions. You have seen that absolute value equations have 2 solutions when the isolated absolute value expression is equal to a positive number. When the absolute value is equal to 0, there is a single solution because 0 is its own opposite. When the absolute value expression is equal to a negative number, there is no solution because absolute value can't ever be negative. So isolate the absolute value expression in each equation to determine if the equation can be solved, and if so, finish the solution. If not, write no solution. So they started here by subtracting 2 from both sides, so 12 minus 2 is 10. Then they divided by negative 5. 10 divided by negative 5 is negative 2. But if we plugged any value in for x, we would always get a positive number out of this function because its absolute value, so it cannot be equal to negative 2. Therefore, it has no solution. B, first they add 3 to both sides, so that gives them 0. Then they multiply both sides by 5/3. That's the same as dividing by 3/5. The 5's divide out, the 3's divide out, so they're left with the absolute value of 2x minus 4. And if you multiply 5/3 times 0, you still get 0. So 2x minus 4 is equal to 0, but we can't do a 2x minus 4 equals negative 0 because that would just be 0, because 0 is its own opposite. So we only need to worry about 1. So then we add 4 to both sides. 2x equals 4. Divide both sides by 2, and you get x equals 2, meaning it has one solution. Now let's check these ones down here. First, subtract 7. Then divide by 3, sorry. But an absolute value function cannot equal a negative number, so this has no solution. Here, subtract 7. Divide by 9. Then take it out of absolute value and do the positive and negative version. But there is only one form of 0, so we just have 4/3 x minus 2 equals 0. There is no opposite version of 0. It is its own opposite. Then we add 2 to both sides. So 4/3 x equals 2. We can then multiply by 3/4 on both sides. The 3's divide out, the 4's divide out. So x equals 2 times 3 is 6/4. Or we can reduce that to 3 over 2, or we can say that is 1.5. Why is it important to solve both equations in the disjunction arising from an absolute value equation? Well, if we only pick one and solve it, then we're only going to get one of the solutions. We have to look at both so that we can determine both of the points where it crosses, both of the places where they intersect. Discuss how the range of the absolute value function differs from the range of a linear function. Graphically, how does this explain why a linear equation always has exactly one solution when the absolute value equation can have 1, 2, or no solution? The range of absolute value functions is only positive. You can only get out positive values when you plug something into an absolute value function. A linear function, on the other hand, can have negative and positive outputs. So in a graph, a linear function only crosses a number in one place, but an absolute value function can cross in 2 spots, 1 spot, or no spots. So to put that in words, linear functions cross the constant functions in exactly one place, or absolute value functions, on the other hand, intersect constant functions above the vertex, giving them 2 solutions, at the vertex, which would give them 1 solution, or below the vertex at those negative numbers, which gives them no solution. You can think of this as also if it has a positive number on the other side, if it has 0 on the other side, or if it has a negative number on the other side. Describe in your own words the basic steps to solving absolute value equations and how many solutions to expect. So step 1, isolate the absolute value expression by moving all other terms to the other side. Step 2, remove the absolute value expression from the absolute value bars and create 2 equations. And they will be opposites. Then we solve both of those equations. We would expect 2 solutions, but there could be 0, 1, or 2. Keep in mind, if when we move the absolute value expression and the other terms to the other side, if it equals a negative, that is going to be that 0 solution problem.